Okay, so the concept of a derivative function quite often catches everybody out because it's conceptually difficult to understand, but really once you actually kind of get your understanding around the important characteristics of a derivative function, it's really actually quite simple. So you've got to learn, it's pretty much a case of you've got to learn the facts about it. And the good news is that really it doesn't get asked in very different ways. So once you've pretty much got the understanding, you've got it, okay. So I just want to start with a few basic concepts over here. So I've given you a cubic function. Cubic, obviously I recognize it's cubic because it's to the third degree of x, okay. Find me the first derivative. Well, the first derivative of the cubic function that's been given to us here is simply 6x squared minus 6x minus 1. Okay. What kind of equation have we now created? Well, we've gone from cubic for our original function to quadratic for our derivative function. Okay. So if your cubic function was like so, where it had two x-intercepts, well, then your quadratic function would land up just having I said two x-intercepts, it's two turning points. Your quadratic function would have just the one turning point, okay? So it's a parabola, all right? And if I found the second derivative, well, the second derivative of that would land up being 12x minus 6, and that as a graph would land up being linear, okay? So that's the first thing that we need to be clear on, is that if you've got a cubic function, your first derivative function is going to be a parabola. The second derivative function is going to be a straight line graph, okay? So now that we understand that, in the next video, we're going to have a careful look at what are the specific points. So if I've got turning points on the cubic graph, what does that translate to in the derivative graph, okay? So we'll have a look at that, so make sure that you stay watching, look at the next video so you understand this nicely. See you now.